Welcome to Spring LIB.
We're asked to find the maximum area of a rectangle that can be circumscribed about a given rectangle with length big L and width big W. So I'll draw a figure to sort of help us explain this problem. So we have our interior rectangle with length big L and width big W. And then we want to draw another rectangle around this. It's circumscribed, so it's going to touch this other rectangle at its corners, like this. These are supposed to be right angles. Like this. It's sort of hard to see, but now I'll just call this angle here theta. I'll call this length A, this length B, this length C, and this length D. Now, looking at our figure, it's clear that the sine of theta on the one hand is A over big W, because this angle here is also theta.
Do you ever get woken up when someone's fucking you? Check this shit out. Okay, I'm watching. So it takes his little purse out. Ooh, wow, we got a key. Yeah. Damn, imagine how much
We also have that the cosine of theta
okay spot outside to sleep. Put a rope down
is equal to B over big L.
Who the fuck is this? Who's this guy? Not wearing a shirt.
So solving for A and B, A equals big W sine theta, B equals big L cosine theta, and therefore we have the length of this side of the rectangle A plus B is big W sine theta plus big L cosine theta. Now, using the same figure, we also have that the cosine of theta is also equal to C over big W, and that the sine of theta is equal to D over big L. And then we can solve for C and D. So C equals big W cosine theta, and D equals big L sine theta. And by symmetry, we have the length of this other side. So the width of the larger rectangle, C plus D, is W cosine theta plus L sine of theta. Therefore, we have that the area of our outer rectangle, A, this is little a plus b times little c plus d, which we have found this is W sine theta plus L cosine theta. W cosine theta plus L sine theta. And so we can obtain our area as a function of theta. Now, if you simplify, we have A of theta is W squared sine theta cosine theta plus WL sine squared theta. plus WL cosine squared theta.
So what, those guys were warning you, or they were just like? No, they're like dumb hicks that live in the fucking woods or whatever.
Plus L squared sine theta cosine of theta. And this simplifies to, we can use trigonometric identities to get A of theta equals 1/2 L squared plus W squared sine of 2 theta plus WL.
So there was a fucking blizzard, I guess. Yeah, this shit sucks. I drove here, took a 2 hours.
Now, just by looking at the equation, we don't even really have to use any calculus. It's clear that
I like what everybody else likes.
A has a maximum
It's fun to get snowed in. You don't like to get snowed in?
when the function sine of 2 theta has a maximum. Of course, the max value of sine of 2 theta is 1, so we want to find when sine of 2 theta equals 1. This means that 2 theta is equal to pi over 2, or theta equals pi over 4. And therefore, our maximum area is A of pi over 4, which is 1/2 times W squared plus L squared times 1 plus WL, which is the same as 1/2 times W plus L squared. And so the maximum area is 1/2 W plus L squared.
How about I fucking piss inside